Hello students. Today we will start with physics topic 10. Motion in a straight line part 2.
Let us start with the welcome message. Dear students, welcome to our channel experiencetutor.com. In this channel, we will teach physics, chemistry, mathematics and biology for the students of class 10th, 11th and 12th and those who are appearing for the school board examinations and entrance examinations like IIT, NEET and all state level engineering and medical examinations. This course is organized according to different topics for each subjects. Therefore, it contains separate video for each and individual topics. Hence, it covers complete syllabus for CBSE, ICSE, ISC and all the state board examinations and engineering and medical examinations. You can also find the relevant topics for foreign school examinations like SAT, IGCSE, IB, etc. Enjoy your learning. Thank you.
Derive and explain the equations for motion in a straight line. When a particle is constrained to move on a straight line, the description becomes fairly simple. We choose the line as the x-axis and a suitable time instant as t is equal to 0. Generally, the origin is taken at point where the particle is situated at t is equal to 0. The position of the particle at time t is given by its coordinate x at that time. The velocity can be found by the below derivation. Suppose the acceleration of a particle is a and remains constant. Let the velocity at time 0 be u and velocity at time t will be v. Thus dv by dt is equal to a or dv is equal to a dt. Or if we integrate both the sides with lower limit as u and upper limit as v and on left and upper limit as t on right hand side, then the expression will be u lower limit v upper limit integration dv is equal to 0 lower limit t upper limit integration a dt. As the time changes from 0 to t, the velocity changes from u to v. So on the left hand side, the summation is made over v from u to v, whereas on right hand side, the summation is made on time from 0 to t. Evaluating the integrals, we get v, u and v is equal to a t 0 to t. On solving this, v minus u is equal to at, v is equal to u plus at. This is the first equation for motion. Equation 1 may be written as is equal to u plus at. Here we have written dx by dt instead of v. Cross multiplication, it will give dx is equal to u plus at into dt. Integrating both the sides, 0 to x dx, 0 to t u plus at dt. At t is equal to 0, the particle is at x is equal to 0. As time changes from 0 to t, the position changes from 0 to x. So on the left hand side, the summation is made on positions from 0 to x, whereas on right hand side, the summation is made on position from 0 to t. Evaluating integrals, the above equation becomes x lower limit 0 to x is equal to integration 0 to t u dt plus integration 0 to t a t dt, or x is equal to u 0 to t dt plus a 0 to t t dt. On solving this, we get u t 0 to t plus a t square upon 2 0 to t. Upon solving, we get x is equal to ut plus half at square. This is the second equation of motion. From equation 1, if we square both the side, we'll get v square is equal to u plus at whole square. Upon solving right hand side, we will get u square plus 2uat plus a square t square. Upon simplification, we get u square plus 2a ut plus half at square. Instead of ut plus half at square, we can write x. Therefore, the final equation is v square is equal to u square plus 2ax. This is the third equation for the motion. Now we will study the various position and time graphs and their interpretations. First scenario. In the first figure, we can see theta is equal to 0 degree. So velocity v is equal to 0. That is, line parallel to the time axis represents that the particle is at rest. In the second case, we can see theta is equal to 90 degree. So velocity v is equal to infinity. That is, the line perpendicular to the time axis represents that particle is changing its position, but time does not changes. It means particle possess infinite velocity. Practically, this is not possible. Third case, we can see theta is equal to constant. So velocity v is equal to constant and acceleration is equal to 0. That is, line with constant slope represents uniform velocity of the particle. In the next case, we can see theta is increasing, so v is increasing, a is positive. That is, line bending towards position x represent increasing velocity of particle. It means particle possess acceleration. In the next scenario, we can see theta is decreasing, so velocity v is decreasing and acceleration a is negative. That is, line bending towards time axis represents decreasing velocity of particle. It means the particle possess retardation. In the next scenario, we can see theta is constant but greater than 90 degree. So v will be constant but negative. That is, line will be negative slope represent that particle returns towards the point of reference, negative displacement. In the next scenario, we can see straight line segments of different slope represents that velocity of a body changes after a certain interval of time. In the next scenario, we can see a graph. This graph shows that at one instant the particle has two positions, which is not possible. In the next graph, the graph shows that particle coming towards origin initially, and after that it is moving away from the origin. Various velocity time graphs and the first graph we can see theta is equal to 0, alpha is equal to 0, v is equal to constant, that is line parallel to the time axis represents that the particle is moving with constant velocity. In the next graph we can see theta is equal to 90 degree, alpha is equal to infinity, v is increasing. That is line perpendicular to the time axis represents that the particle is increasing its velocity, but time does not changes. It means the particle possesses infinite acceleration. Practically, it is not possible. In the next graph, we can see theta is equal to constant, so alpha is equal to constant, and v is increasing uniformly with time. That is, line with constant slope represents uniform acceleration of the particle. In the next graph, we can see theta increasing, so acceleration increasing. That is, line bending towards velocity axis represents increasing in acceleration. In the next graph, we can see theta is decreasing, so acceleration decreasing. That is, line bending towards time axis represents the decreasing acceleration in the body. In the next graph, we can see positive constant acceleration because theta is constant and less than 90 degree, but initial velocity of the particle is negative. In the next graph, we can see positive constant acceleration because theta is constant and less than 90 degree, but initial velocity of the particle is positive. In the next graph, we can see negative constant acceleration because theta is constant and greater than 90 degree, but initial velocity of the particle is positive. In the next graph, we can see negative constant acceleration because theta is constant and greater than 90 degree, but initial velocity of the particle is positive. In the next graph, we can see negative constant acceleration because theta is constant and greater than 90 degree, but initial velocity of the particle is 0. In the next graph, we can see negative constant acceleration because initial velocity of the particle is negative. Define equation of motion if a body dropped from some height, initial velocity 0. First equation of motion. Taking initial position as origin and direction of the motion, that is downward direction, as a positive, here we have u is equal to 0 as the body starts from rest, a is equal to plus g as the acceleration is in the direction of the motion. Therefore, from the first equation of motion, v is equal to u plus zt. V is equal to, since u is equal to 0, therefore v is equal to zt. The second equation will be converted to h is equal to half gt square. Define equation of motion if a body dropped from some height. Initial velocity is equal to 0. First, equation of motion. Taking initial position as origin and direction of motion downward direction as positive. Here we have u is equal to 0 as the body starts from rest. A is equal to plus g as the acceleration is in the same direction of motion. Therefore, first equation of motion can be converted as v is equal to zt. Second equation of motion can be converted as h is equal to half gt square. And third equation of motion can be converted as v square is equal to 2gh. Therefore, hn is equal to g by 2 bracket 2n minus 1. If we plot the graph of distance, velocity and acceleration with respect to time, then the graph will be as below. If a body is projected vertically downward with some initial velocity, then equation of motion will be v is equal to u plus gt, h is equal to ut plus half gt square, v square is equal to u square plus 2gh, hn is equal to u plus g by 2 bracket 2n minus 1. If a body is projected vertically upward. Case 1. If the body is projected with velocity u and after time t it reaches up to height h, then v is equal to u minus gt, h is equal to ut minus half gt square, v square is equal to u square minus 2gh, hn is equal to u minus g by 2, 2n minus 1. Case 2nd. For maximum height, v is equal to 0. So, from above equation, u is equal to zt, h is equal to half gt square, and u square is equal to 2gh. Graph of distance, velocity and acceleration with respect to the time for maximum height will be as below. And this is the end of this topic. If you like this video, please subscribe our channel and give us a like sign. Please click on the bell icon so that you get automatic notification when a new video is uploaded by us. Thank you for watching our channel.